Hello students, now we will discuss about the equations of motion of the unit number second. So equations of motion we have to discuss here by the graphical method. And to solve the equations by the graphical method, we have to draw a graph here. First of all, graph is drawn between the x-axis and y-axis, or we can say the body is moving in xy plane, and we have to draw the graph of the body which is moving with the uniform velocity. So we have to consider here, suppose the body is moving in a uniformly motion with the initial velocity u. So let u is the initial velocity of the body moving with uniformly along a straight line, and it acquires a velocity v after t interval of time. So v is the final velocity and t is the time taken to obtain the velocity from the u to v. Now draw the perpendicular line CA and CD. So CA, it's a perpendicular on the x-axis, and CD is the perpendicular line on the y-axis. So the graph enclosed by the point E to C, it is divided into two parts. One part is OABE. It's a rectangular part, and the graph EBC, it's a triangle part. So we have to solve by this graphical analysis the first equation of motion. So we have to consider here, when the body is moving with initial velocity u and acquire the final velocity v in an interval time t, then it acquires some acceleration. So suppose a is the acceleration acquired by the body in the interval of time from 0 to t, then according to the definition of acceleration, that is a equal to change in velocity, divided by time taken. So from this formula we have to find out the acceleration of the body. So acceleration in symbolically acceleration, change in velocity. So final velocity is v at the point C. If when the line is drawn, it is find out magnitude by magnitude on the y-axis, it is equal to up to v, and this is the initial velocity u. So difference of these two, that is equal to bc. So v minus u, amount of velocity is acquired, that is the change in velocity. So change in velocity is final velocity minus initial velocity equal to time taken. So final time t minus initial time 0. So from this formula we can find out the change in we can find out the acceleration. So acceleration a will be equal to v minus u upon t, and from this formula if we cross multiply, then we can find out the value, that is a into t, that is at, and equal to v minus u, and the equation can be written as v equal to u in the left side, and then it can be written as u plus at. So this is the first equation of motion. Now after that, from the same graphical method, we have to solve the second equation of motion, and second equation of motion is, that is s equal to ut plus half at square. If we solve that equation, so we have to write second equation. So second derivation for the second equation of motion. So to solve the second equation of motion, again we have to find out the distance covered by the body when the body is moving from initially velocity u to final velocity v up to the point C in a time interval t. how much distance is traveled. So when we find out the distance traveled by the body in the given interval of time t, that distance s, it is always equal to the area enclosed by the graph. This is the formula. The distance traveled by the body in a velocity time graph, the distance can be found out by the area enclosed by the graph. So area enclosed by the graph, though area enclosed by the graph CE, it is the total area from O, A, C, E. This is the total area. So this area is divided into two parts. Number one, that is the area of the triangle, and number two, the area of the rectangle. Now area enclosed by the graph, it is equal to area of triangle, that is EBC plus area of rectangle OABE. Now from this formula we can find out the distance. Area of the triangle, that is formula 1/2 base into height. So base is this EB, and EB equal to the time taken from 0 to t. So it is equal to t into, that is height BC, and BC equal to from the graph V minus U. So we can put here V minus U. This is the area of the triangle. Then rectangle is area equal to length into breadth. So this is the length t, may be equal to EB, and this is equal to the time taken t, and multiplied by the height BT, may be equal to OE, and this is equal to U. So the formula is T into U. Now that simplify the value, and we have to write S equal to 1/2 V minus U into T plus UT. Okay, now replace that value V minus U. We have to use here from equation number 1, we know that V equal to U plus AT. So what about the V minus U? So put here, now put the U in the left side. So V minus U, that is equal to AT. So this V minus U is replaced by AT in the equation. So we will get S equal to 1/2 AT into T, that is T square plus UT, plus that is UT. So S equal to 1/2 AT square plus UT, and this equation can be written as like this: S equal to UT, write down first, then 1/2 AT square next term. So 1/2 S equal to UT plus 1/2 AT square. So this is the second equation of motion, and we can similarly we can solve the third equation of motion. So third equation of motion can be solved by the same graph that is drawn between the xy plane, and in the xy plane we can solve the third equation of motion.